Good morning everyone. My name is K. Banu Prakash from CSM department. Today my topic is about constraint propagation. Topic: constraint propagation in artificial intelligence. Introduction to constraint propagation. Constraint propagation is a technical used in artificial intelligence to reduce the search space of a problem. It involves the systematic narrowing down of possible values for variables based on constraints. This method is particularly useful in solving constraint satisfaction problems (CSPS) efficiently. Constraint propagation: propagating the consequences of a variable's constraint onto another variables. Expect CSP as constraint graph. Nodes are variables, arcs are constraints. Check for a constancy. You look at the diagram. What are the constraint satisfaction problems? CSPS involves finding values for a set of variables under specific constraints. Common examples of CSPS include puzzles like Sudoku and scheduling problems. A solution is achieved when all variables are assigned values that satisfy all constraints. Constraint satisfaction problem (CSP). Set of variables V1 that can take on values from their domains D1. Discrete continuous. Goal test specifics constraints on variable. Unary on a particular variable. Example: leftmost digital in cryptic arithmetic is 0. Binary on pair of variables. Example: n queens problems map coloring. Allowable cross product of domains can be enumerated in restrictive case. Other on more than two variables. Example: many scheduling layout problems. Components of CSPS. A CSP contains of variables, domains and constraints. Variables represent the unknown that need to be solved for. Domains define the possible values that each variable can take. Constraint graph. Binary CSPS. If all the constraints of a CSP affect two variables, the variables and constraints can be represented in a constant graph. Constant network. Nodes represent values, edges represent constraints. Benefits of constraint propagation. Constraint propagation can lead to significant reduction in the search space and computation time. It enhances the efficiency of solving CSPS by preemptively removing infeasible options. This technique often allows for solving complex problems that would otherwise be computation inference. Instantiated variables y1 kcy. Currently instantiated variables vy1, not yet instantiated variables y1 cy. Backtracking, forward checking, look ahead. This is the diagram of constraint propagation. Limitation of constraint propagation. One limitation is that it may not always lead to be a completion solution. In some cases, constraint propagation alone may not sufficient, requiring additional search techniques. Additionally, the overhead of maintaining constraints can be computation expensive in certain constraints. Structure of CSP. If the constraint graph contains multiple components, then one independent CSP per component. If the constraint graph is a tree, no loop, then the CSP can be solved efficiently. Types of constraints. Constraints can be unary, binary, or high order depending on the number of variables involved. Unary constraints relate to a single variable, while binary constraints involve pairs of variables. Higher order constraints involve three or more variables and can be more complex. Applications of constraint propagation. Constraint propagation is widely used in scheduling, resource solution, and configuration of problems. It also efficiently in robotics for pathfinding and motion planning. In artificial intelligence, it underpins many algorithms for automated reasoning and decision making. Instantiated variables y1, cy. You can see in the middle currently instantiated variables y, not yet instantiated variables y1, cy. Backtracking, forward checking in the middle of the diagram, look ahead. Now, real world example Sudoku. Sudoku is a classic example of CSP where constraint propagation can significantly aid in solving the picture. You can see the picture in the right side of the slide. The rules of Sudoku act as constraints that guide the placement of numbers. You can see the placements of number in the different places. Techniques like arc constantly can quickly eliminate impossible placements, speeding up the solution process. Conclusion of this topic is constraint propagation is a vital technique in the field of artificial intelligence for solving CSPs. It enhances problem solving efficiently by narrowing down possibilities through constraints. Understanding and applying constant propagation can lead to more efficiently AI systems. Constraint propagation. Propagate the consequences of variables constraints onto other variables. Represent CSP as constraint graph. Nodes are variables, odds are constraints. Check for constraints. BA to NT, NT to Q, NSW and SA and V to T. Thank you for giving this opportunity. Developed by K. Vanu Prakash. Thank you.